YouTube.
Sweet.
So hopefully people will start coming in, and then we'll start straight up at 5 o'clock.
Yeah, it looks like attendees are kind of coming in.
Oh, you can see?
Yeah, I think if you, I think it'll show in participants. There's another.
Oh, I can see.
Yeah, like
6.
another.
I see 6.
Ooh, yes, that's what I see too.
Yeah. All right, and we are live streaming too, so
Right.
Keep it clean, folks.
Right.
Sweet.
Notice how quiet we got when you said keep it clean.
Well, Greg, I'm interested to hear your talk today. I'm looking forward to. Everybody loves volcanoes. We all love hearing about that stuff.
I hope so. I hope everybody. They are pretty exciting. Yeah. Love talking about them. And it's always a topical topic because there's always something happening somewhere.
Is that something that you specifically studied, or does it just kind of come with the whole job?
I sort of fell into it. There's some luck involved. I've always been interested in volcanoes. Like I think a lot of people, they're just really cool and fascinating. But when I started studying how to use satellite remote sensing tools to study different active processes on the Earth's surface, when I started doing that, that was sort of in the mid-2000s. And actually, I did a postdoc at JPL, and the very first day of my job, day one, when I started, Mount St. Helens started erupting again.
Oh, wow.
October 1st, 2004.
Right.
And we just happened to have some remote sensing airborne systems up there preparing to fly over and collect data. So I got a chance to start using remote sensing tools to study an active volcanic eruption, sort of fortuitously, and I've been doing it ever since.
Cool.
Yeah.
Cool. That's great timing.
Yeah, it was.
Yeah.
It was good timing.
It's amazing what that sort of thing will do. Like, I remember talking with one of the astronomers up at Lowell. It's like, so how did you get into comets? And he was like, well, Halley's Comet was coming through, so that's sort of what you did, and it was a great opportunity, and he wasn't sure what he wanted to focus on, and it literally fell out of the sky for him. So
yeah,
you want to be a part of the big events of your century.
Oh, yeah.
So for the folks coming on, just so you know, we are live streamed on YouTube, so just know that. And as soon as we start at 5, Claire's going to have some housekeeping and then introduce. So we're just chatting right now. It hasn't started yet. You haven't missed anything.
So Sherry, you work at Lowell Observatory?
I do. I do.
I'm an educator there. I don't know if we've ever crossed paths.
I know who you are.
Yeah, okay.
You and I our paths have not crossed.
Yeah.
I think once, like during an event.
I think so.
I think when the Godo opened, it was like, oh, Claire's doing that, and I was like, yeah, I got to go do that.
Yeah.
So,
yeah. Is Godo open for like private tours now? Not public tours, but okay.
It's like limited capacity tour groups. So you can have a mixed group of people, but the capacity is at 15 per tour group. And so you can't wander around campus on your own quite yet. Hopefully soon, but
yeah, okay.
Dates keep changing for that, so I have no idea.
Soon, hopefully soon, things will calm down enough for us to open up properly.
Yeah, and hopefully for the festival next year, the USGS will be able to get back to having open houses and being at Science in the Park.
Exactly. Well, we're straight up 5, so I'm going to go mute and blank, and you guys take it away.
Okay.
Sweet. So before I introduce our speaker this evening, I want to introduce myself. My name is Claire. I'm working for the Flagstaff Festival of Science. I'm just going to go through a couple things so you guys know how this webinar will work if this is your first time joining us. So we will have time at the end of the talk for questions. And what we're going to do for that is use the Q&A function that you can see at the bottom of your screen. So if you have any questions for our speaker, please put them in there. And there's also an upvote function. So if you see another question that you would like answered, or if you have a similar question to someone else, you can upvote that. So the Q&A doesn't get too clustered and so that we can get to all the questions relatively easily. And we're only going to use the chat function if you guys specifically have a pressing tech issue that you're dealing with, and only the panelists will be able to see that chat message. So just keep that in mind in case you're going to use that. So without further ado, I'm going to introduce our speaker and then we can get started. So today's speaker is Dr. Greg Vaughan. Greg is a research scientist at the USGS Astrogeology Center in Flagstaff, Arizona. He specializes in using remote sensing tools and techniques like infrared satellite images to study the ever-changing geologic processes around active volcanoes and geothermal areas. He has also been working with the Flagstaff Festival of Science Board of Directors for many years now. He is a past Board of Director president, currently manages the in-school speaker program, and has been a regular presenter for the after-school talks program. So thanks for being here, and I'll give the time to you, Greg.
Okay, thank you, Claire, for the intro. I'm going to go ahead and start sharing my screen. Let me know if you can see that or can't see it. I'm going to start the slideshow. All good? All right. So thank you for being here. I trust that you'll tell me if you can't see my screen.
Can't see your screen.
Aha, okay. How about now?
There you go.
Okay, thanks. We're good to go. So again, thank you for the intro. Thanks to everyone for tuning in. I hope you all have been enjoying the Flagstaff Festival of Science so far. This is the 4th day of the festival. So there's still 6 more days to go, plenty more to come. So for those of you who know me, you know that one of my favorite things to do is to just sit here and talk about active volcanoes. And for those of you who don't know me, hi, my name is Greg Vaughan. I'm a research scientist at the USGS, and one of my favorite things to do is sit here and talk about active volcanoes. So this year, instead of just talking about 1 or 2 specific volcanoes or volcanic areas, I thought I would talk about a whole bunch of them. So this is going to be a quick summary of the volcanoes that have erupted so far in 2021. And I will highlight some of the ones that are some of the more spectacular ones, the ones with really cool pictures and videos that are available. And I'll talk about a lot of them. So let's dive right in. There are 69 volcanoes that have erupted in 2021 so far. And this map that I'm showing here shows their locations around the world. Now, before yesterday, I was prepared to say that there were 68 volcanoes that had erupted, but just yesterday, this volcano on La Palma Island in the Canary Islands started erupting. So now we're up to 69. And hey, the year's not over yet. We might get a couple more eruptions, but for right now, 69 eruptions now have erupted this calendar year. 69 is a pretty typical number. A lot of times I hear the question, is volcanic activity increasing? Is the number of volcanic eruptions increasing? And the short answer is no. Sometimes it might seem that way, but that's really just a function of increasing population of people around active volcanoes that can observe maybe small eruptions that may have gone unnoticed in the past. And it's also a function of improvements in and increased access to technology for recording, reporting, and hearing about eruptions. We have this 24/7 news cycle, and we have the internet and almost instantaneous global communications. So it's hard for a volcano to go unnoticed these days. But if you look at a graph, of the last 30 years of annual eruptions, you can see that having 69 eruptions is sort of right in the middle there. This is a graph showing the total number of annual eruptions going back 30 years. And there's no real up or down trend here. It sort of bounces around between 55 and almost 90 eruptions in a year. So we're right in the middle of that. And if you were to look at data going back through historical records, say a couple of hundred years, and look at just the really large eruptions that almost everybody has known about, you'd see, again, a pretty flat trend. So there's no evidence and no good, therefore no good reason to think that the number of annual eruptions is either increasing or decreasing. It's pretty flat. So 69 volcanoes this year. As of right now, there are 51 of these volcanoes are still erupting, or at least still exhibiting significant signs of unrest, like earthquakes, ground deformation, magmatic gas and ash and lava and heat emissions. And 18 of these 69 eruptions have stopped, or at least have appear to have stopped, at least for now. Another question that's interesting is just to ask, well, when did all these eruptions start? So of the 69 volcanoes that have erupted this year, 22 of them actually started erupting in 2021. And of those 22, 14 of them have already stopped. So these were some pretty short-lived eruptions, lasting only days to weeks to months. And the other 47 of these 69 2021 volcanoes are volcanoes that are just continuations of eruptions that have been going on for some time. And it's kind of interesting to look at these other eruptions. Many of these other eruptions that are continuing have started just in the last 10 or 20 years. And that's also pretty common for an eruptive period to last for decades. Kilauea volcano, for example, in Hawaii, erupted nearly continuously from 1983 until 2018, about 35 years. But some of these volcanoes that are really impressive for how long they've been erupting. So I want to highlight a few of these. The first one I want to talk about is Mount Erebus in Antarctica. Yes, there is a volcano in Antarctica, one of the coldest places on Earth. There's an active volcano. It's actually so far south, it's off the edge of my map here. So my little icon is down here, but it's pretty much due south of New Zealand on an island called Ross Island off the coast of the continent of Antarctica. And Mount Erebus has an active lava lake at the surface, a actively boiling lake of lava that occasionally explodes and spits molten material out into the icy rim. And that thing has been active since at least 1972. Another one, Erta Ale volcano in Ethiopia, one of the hottest places on Earth, also has an active lava lake that's been there since at least 1967 and probably even earlier than that. Another volcano that's notable for how long it's been there is Stromboli Volcano off the west coast of Italy. This is the northeasternmost of the Aeolian Islands, north of Sicily. And it's been in an active eruptive period since 1934. And it has mild lava spattering explosions and sometimes lava flows, kind of like pictured in this image here, on and off for more than 1,000 years. So Stromboli is sometimes called the lighthouse of the Mediterranean because it frequently looks like this. To the south, Mount Etna, Stromboli's very active volcanic neighbor to the south on the island of Sicily, also has a very long history of recorded eruptions going back more than 3,000 years. But Etna has also had some really spectacular eruptions earlier this year. So I'm going to talk a little bit more about Mount Etna a little bit later. A few other volcanoes that are notable for how long they've had active eruptive periods. We have Dukono volcano, which is in Indonesia. It's had nearly continuous explosive eruptions, sometimes lava flows, since 1933. Santa Maria volcano in Guatemala is an explosive stratovolcano. And at the base of the crater, there's a group of lava domes there that have been growing. Sometimes they extrude onto the surface, and sometimes there are explosions, pyroclastic flows, and sometimes lahars. And that's been going on since 1922. Okay. And lastly, we have Yasur volcano, which is on the in Vanuatu. And this volcano has had nearly continuous lava spattering and ash eruptions since it was observed by Captain Cook in 1774. So I think that's pretty amazing. So some volcanoes can have eruptions or periods of really frequent eruptions that last for many decades or even centuries. And some eruptions last for just weeks to months. Now, the period of time between eruptive episodes is also varies really widely. Some volcanoes have periods of repose or dormancy that last for just weeks or months. And some volcanoes have decades or centuries or even longer of periods of repose or quiescence. For example, in southern Chile, there's a volcano called Chaitén volcano that erupted in 2008 after more than 9,000 years of silence. So it's pretty amazing that volcanoes that have been quiet for a really, really long time can sometimes come alive again. And that's one of the reasons that it's so difficult sometimes to understand volcanoes and sort of make forecasts about eruptions, because there's so much variety in the timing of volcanic processes and you know, how long they erupt and how long they're quiet. It's different for every volcano. They all sort of have their own sort of personality. Now, in general, any volcano that has erupted or has exhibited significant signs of unrest or has geologic evidence of an eruption in the last 11,700 years is considered to be an active or a potentially active volcano. So why 11,700 years? Because that is the time frame of the current geologic epoch that we're living in. It's called the Holocene epoch. Okay, and so to answer a common question, how many active volcanoes are there? There are about 1,356 Holocene volcanoes. So that is volcanoes that have erupted or are suspected to have erupted based on geologic evidence in the Holocene epoch. Okay. Now, there are some volcanoes that haven't erupted in a much longer period of time, like Yellowstone hasn't had an eruption in 70,000 years, but it's conceivable that that could erupt again someday. So there are a few older volcanoes that could erupt. And so there's nothing magic about the 11,700 number. That's just sort of the line that we draw right now. And this does not include many volcanoes that are located deep underwater, which is actually where most volcanoes are, if you think about the mid-ocean ridges. And there are still debates about whether only confirmed eruptions should be considered and what time frame should be considered and how to define the word active and potentially active. And there are debates about whether large volcanic fields should be considered just one volcano or multiple volcanoes. And so the answer to this question, how many active volcanoes are there, is sort of bounces around a little bit depending on who you ask and when you ask them. And as new research comes in with new age dates and our new understanding of volcanoes, you know, this number will bounce around a little bit. But for now, this is a good estimate of the volcanoes that could potentially erupt again in the future and pose hazards to people. And here's a map of where they all are on Earth. And by the way, there are about 1 billion people on Earth who live within about 100 kilometers of an active volcano. And that's why it's so important to study them and monitor them. So before I move on, I want to give a shout out to a couple of organizations. We have the Smithsonian Institution's Global Volcanism Program and the USGS Volcano Hazards Program, which these are the sources of much of the information that I'm going to be presenting here today. So the Global Volcanism Program has been documenting and sharing information about Earth's volcanoes for more than 50 years. They do research and outreach and archive data and report on active volcanoes around the world. They maintain this database of Holocene volcanoes, and anybody can go to their website here and learn about any one of these, learn a lot of information about any one of these Holocene volcanoes. And they also have a weekly update that comes out every Wednesday about current global volcanic activity. So every week this map gets updated. This is the map from last week, ending September 14th, showing all the volcanic activity that's all the sort of the new, any significant changes in volcanic activity over the last week is shown on this map here. Now in the USGS, the Volcano Hazards Program is responsible for studying and monitoring potentially active volcanoes, assessing hazards, and conducting research so that they can issue warnings of potential volcanic hazards to emergency managers and land managers and to the public. You know, the USGS is focused primarily on the 161 potentially active volcanoes in the US, but they also work with the Office of US Foreign Disaster Assistance, which is part of USAID, the Agency for International Development, to provide assistance and resources to help reduce risks from volcanic hazards, primarily to developing nations. And this is called the USGS Volcano Disaster Assistance Program, or VDAP. And I could say that working with VDAP is one of my tasks with the USGS. I spend a little bit of time doing activities for VDAP, and it's one of the things I really enjoy a lot. I really enjoy an opportunity to sort of be on the front lines of a response to a volcanic crisis. So let's get back to talking about this year's volcanoes. The first one I want to highlight is Kilauea Volcano in Hawaii, all right? So as you all may recall, in 2018, Kilauea had a very spectacular, very significant eruptive episode where the lava lake at the summit drained away and lava erupted through a series of fissures in the middle of a subdivision in the lower East Rift Zone, some 40 kilometers away. There were several months of really spectacular lava fountaining and rivers of lava that reached the ocean. Unfortunately, destroying more than 700 structures, many of them homes. Thousands of people were displaced, but there were no fatalities and only a couple of injuries that I know of. Meanwhile, up at the summit collapsed, making Halema'uma'u crater in the summit caldera 500 meters deeper. So this is what the summit looked like in 2018 when the eruption started in May. Well, before the eruption started. And this is what it looked like after the eruption was ended, which ended by December 2018. I mean, there's a huge change there in downdrop, 500 meters of downdrop in this crater. And so so the lava lake's gone and just as a big pit there. And so in the following months, water started to fill it up. By July 2019, a water lake started forming in this newly deepened crater as groundwater seeped in from below and rainwater fell down from above, although it was mostly groundwater seeping in. So it started as a little puddle, and then it was a pond, and then it became a lake, and it increased in size over the next year until it was about 250 meters across. And so this animation is a series of images that shows the lake growing over the following months. And so this continued until December 2020, when a new eruption started. So this next image I'm showing you is actually a thermal infrared image of the water lake. It measures temperature, and the lake ranged in temperature from 75 to up to 85 degrees Celsius, which is about 185 degrees Fahrenheit. Not something you'd want to go swimming in, much too hot. Also, it was slightly acidic with a pH of about 4.2. But on December 20th, 2020, 9:30 p.m. local time, boom, a new eruption started at the summit. A series of vents opened up along the edge of this steep slope, and lava erupted not from underneath the water, but from some vents on this slope, and the lava plunged down into the water lake. And that's a thermal infrared image showing that. And so here's a video, a picture. And the next one, I might as well just show the video because, hey, it's a video. This is a video of about a 50-meter high lava fountain coming out, and then the lava is cascading down into the bottom. It only took about 90 minutes to completely evaporate that water lake that was there. And so a lava lake took its place. Pretty impressive. And so this happened in December 2020. And the next video I'm going to show you is a series of images from a thermal infrared camera covering, let me go to the next video here. Here's the thermal infrared camera, again, looking at the water lake. This image is covering 4 months, from November, about a month before the eruption started, until March 2021. And this is going to fly through pretty fast. But what it shows is how the water lake's there, and on December 20th, all of a sudden, boom, the eruption happens, and the lava lake that forms grows. It evaporates the water lake really fast, and it grows, rises really fast. And you can see sort of islands of cooled lava floating around in the molten lava. At first, they were moving around, and then they sort of became stationary. I'm going to show that again because it goes so fast. There's a couple of interesting things to see here. On the left side of this picture, which is north, the most active vent got covered up and drowned out pretty quickly, and then activity shifted to the west side of the crater, And then for the rest of the growth of this lava lake, the west side of the crater was the most active. The east side of the crater cooled off more quickly. And these are all images from a thermal infrared camera. Here are a couple of more visible images nighttime, so you can see the incandescence. Pretty impressive lava lake that formed there. And it continued to grow slowly until it finally finished. By May 2021, the eruption was over. Lava had stopped flowing in and the lake crusted over, leaving a new caldera floor that was about 229 meters higher than it was before. They estimate that about 41 million cubic meters of lava erupted, which is enough to fill about 30 large football stadiums. So all in all, pretty small eruption, okay? Now, there was a slight uptick in activity last month when there was a swarm of earthquakes and some ground deformation at the Kilauea summit. But that unrest has now settled down, and Kilauea is just resting now, hanging out. There's no way to know when it might erupt again, but it almost certainly will someday, not too far in the future. All right. So now let's go halfway around the world to Mount Etna volcano, which is located here. I'll go to the next slide here on the island of Sicily. This is the tallest and most active volcano in Europe. And as I said before, it's one of the most active volcanoes in the world, with records going back more than 3,000 years with accounts of eruptions. So the current eruption is not new. It's been going on since 2013. But in February 2021, earlier this year, there was a period of really ramped up intensity and lava spattering, or Strombolian eruptions. They're called Strombolian eruptions, named after the Stromboli Island. Strombolian eruptions were coming up from multiple vents at the summit at the same time. And over the last 6 months, there have been a series of more than 50 distinct, really intense lava fountaining episodes that are called paroxysms, where incandescent lava spatter reached up to 1,500 meters, 1.5 kilometers high. That's just incredible. Just think about the force it takes to propel molten rock that high into the air. And because of this recent activity, Etna has actually gotten taller. In the last 6 months, it's about 30 meters taller. So let's take a closer look at the summit. Here's a nice photo of the summit region at Mount Etna on a clear day when it's not erupting. And there are multiple craters at the summit, explosion craters. There's we're looking north here. So this crater here, the northeast, is called the Northeast crater. It's been there for like 100 years. And there are a couple of nested craters in the center here. One is called Voragine crater, which means chasm. I think I pronounced that correctly. And the other one's called Boca Nuova crater, which means new vent. But these vents formed between 50 and 70 years ago. And then on the southeast side, there's a younger crater called the Southeast crater, which formed in 1971. And recently, this has been the most active crater. And this is actually the region that has increased in elevation and is now the highest peak on the whole mountain. So back in December 2020, there was nearly continuous Strombolian activity at the summit. Again, Strombolian activity is mild, explosive lava spattering and fountaining, coming from multiple summit craters. And you can see that up here, feeding lava flows that were going down the flanks. Here are a few images from that time, a couple of thermal infrared images where you can see temperature differences, and of course, visible images at night where you can see incandescence coming from different places at the summit. Then in January 2021, the activity increased a little bit in the central and eastern craters. Lava flows came down the east flank, as you can see from this map here, from January 18th, 2021. And there were multiple active vents in all the summits, but the most active vent was the Southeast crater, which was producing enough material to feed lava flows coming down the east flank there. And then in February, there were simultaneous Strombolian eruptions from all 4 of the summit craters all at the same time, which apparently hasn't happened in like more than 20 years. And there was just an increase in the intensity of the fountaining. So, and like I said before, some of the fountaining episodes sent lava spatter up 1,000 meters, 1,500 meters into the air, which is just amazing. These paroxysms of incandescent ejecta were also accompanied by ash plumes, which you can see in the center photo here, and also lava flows. Now, each of these episodes, and there, like I said, there have been more than 50 in the last 6 months, they last for a few hours, maybe some of them 6, 8, 10 hours. And then they tend to be followed by lava flows. They feed, these fountaining feed lava flows that last for a few more hours. And then there's a couple of days of just nothing. And then a few days later, another one happens. It lasts for hours, and then lava flow lasts for hours, and there's a couple of days of a break. And so, but the accumulation of lava and these pyroclastic or explosively ejected material produced by these eruptions has made the rim of the southeast crater actually a little bit taller. So here's a digital elevation model of the summit showing the southeast crater is now the highest peak on the mountain, and it's measured at 3,357 meters above sea level, which is 11,013 feet elevation. You may be wondering how did they measure the elevation? Did they send a grad student up there with some survey equipment and GPS? No, probably not. It's interesting because the new elevation was actually determined using remote sensing image analysis technique called stereophotogrammetry. There is the French have a commercial satellite system that's called a really high resolution commercial satellite system called Pleiade, or Pleiades in English, but I think it's pronounced Pleiade in French. This is a really high resolution satellite that is capable of acquiring stereo imagery at really high resolution over anywhere. And so using these data, using stereophotogrammetry, they were able to determine the new elevation of this peak using remote sensing methods. So I think that's pretty cool. Lastly, here's a really nice video of some of the paroxysms of this in the last 6 months, showing Mount Etna really kicking up, really high spattering. By the way, fun fact for Star Wars fans out there like me, in the movie Star Wars Episode 3, Revenge of the Sith, everyone's favorite, right? Just kidding. There's a volcanic planet called Mustafar. This is where Obi-Wan and Anakin have their lightsaber battle. Some of the lava explosions in the background of the lightsaber battle scenes were actual lava explosions filmed on Mount Etna by a Star Wars cinematographer who visited there when it was erupting back in 2002. And they incorporated these lava explosions into the background of the lightsaber battle scenes. Isn't that cool? All right, so let's go to another volcano. Let's move to Iceland now. All right, now there's been some really spectacular volcanic activity in Iceland this year. So here's Iceland. Iceland is a very large, relatively large island in the North Atlantic, formed entirely by volcanic activity. The Iceland hotspot, which originates deep in the Earth's mantle, is responsible for a huge pile of volcanic rocks, mostly basalt, sitting on the top of the North Atlantic Ocean floor. The island of Iceland is kind of like the tip of an iceberg. It's just the part of this pile of volcanic rocks that's currently sitting above sea level. Tectonically, Iceland is also coincident with the Mid-Atlantic Ridge spreading center, where the North American plate and the Eurasian plate are being pulled apart. So this is actually one of the most volcanically active regions in the world. There are more than 30 Holocene volcanoes here, and they're mostly located along these regions, these volcanic zones, pretty much coincident with the Mid-Atlantic Ridge spreading system. And the eruption that I'm going to be talking about is that's been happening is located on the Reykjanes Peninsula, just south of Iceland's capital city of Reykjavik. Now, this is a region that hadn't had an eruption in more than 800 years, maybe longer, many, many centuries. But in late February 2021, it started to wake up again. Actually, there were signs that magma was intruding into this area more than a year before. As early as December 2019, there were swarms of earthquakes indicating magma moving around underground. But on February 24th, 2021, there was a pretty good size, magnitude 5.7 earthquake that was felt widely across the region. And that was then followed in the next 3 weeks by more than 50,000 earthquakes leading up to the eruption, which is astonishing. Here on the left here, I'm going to show a short video of just the first 20,000 of these earthquakes. When February 24th hits, you're going to see a real boom. There we go. So all of a sudden, lots and lots of earthquakes happening. And the map on the right is sort of an accumulation of almost all of these 50,000 earthquakes that shows where they were. And so the locations of the bulk of these earthquakes indicate where magma was intruding into the shallow crust. And there were also measurements of ground deformation in this area. Most of these earthquakes were small, not felt by anyone. But some of them were large enough to be felt. And in early March, in the early part of March, earlier this year, many of the residents in this region were losing a lot of sleep, apparently, not because they were worried, but because they were being awakened by earthquakes all night long, constantly, all day long. And there are thousands per day, many of them felt per day. So that's just a lot of ground shaking. It's kind of unnerving. But then on Friday, March 29th, let me go to the next slide here. At 8:45 p.m. local time, a 700-meter long fissure opened up right here where this red line is, and a new eruption started. Here are a few pictures early on in the eruption. It's out in the middle of kind of an uninhabited area. Multiple vents opened up along a fissure system and started forming little spatter cones. Go to the next slide here. This is a nice photograph that shows sort of the delineation of this fissure and the locations of vents. What tends to happen is that the lava spattering will end up concentrating at a few locations and then ultimately converge into one vent location, which ends up building the tallest cone. And in this case, it was actually vent system number 5 that ended up sort of taking over and being the main one here along this original fissure. This image is from April 2021 and shows a lot of different vents. And then this image is a month later in May. You can see that this vent 5 system is sort of taken over and sort of flooded and covered up many of the other vents. Now let me say something about the name. You may have noticed that I've been avoiding saying the name of this volcano. The name of the pre-existing volcanic plateau that's been there for centuries is called Fagradalsfjall. Okay, I've been practicing. Fagradalsfjall. This means the mountain of the beautiful valley, which is actually a pretty cool name. And the fissure that opened up right next to it. And so many of the references to this eruption use the name Fagradalsfjall. And I hope I'm pronouncing that correctly. Apologies if I'm getting it wrong, but I'm trying my best. Now there's another little valley right next to it called Geldingadalur or Geldingadalur, depending on how it's spelled. And that's where most of the lava flowed initially. It started filling up this valley. Now, Geldingadalur can be interpreted as meaning infertile valley. But that's not because nothing grows there. It's actually because apparently this is where farmers grazed their castrated rams. A gelding is a castrated animal, usually a horse, but it could be any animal. So I suppose another name for this valley is Castration Valley, which is not the nicest name, really. So I guess the people who live in the nearest town get to vote on what this is going to be called. And the eruption, the magmatic system that produced this eruption is not the same as the magmatic system that produced the Fagradalsfjall eruption. So I don't think that's what they're going to end up calling it. Now the name Hrun, the word Hrun means lava field or lava. So I think what they're going to do is sort of tack this word onto the end of it. And they're going to end up calling this the Fagradalsfjall eruption, which means lava of the beautiful valley, which is kind of a cool name. So the name, which I have up on the top here, Fagradalsfjall, I think is the correct pronunciation of this. And I think that's the name that's going to stick. Okay, so the other thing about this eruption that is really interesting is that despite despite a long hike over rough terrain and sometimes rough weather to get out there, it's apparently quite accessible because it has become a major tourist attraction. Since the eruption began, more than 300,000 people have visited there. There have been parties there. There have even been wedding ceremonies there. which is awesome if you think about it. Can you imagine getting married in front of an advancing lava flow? That would be cool. It kind of puts a time limit on the end of the ceremony. You know, you can be like, let's move things along now. It's getting hot. You know, skip to the end, right? So because it's so accessible and highly visited, there are thousands of really cool photos and videos you can find online, and a whole lot of people have gone out there with their drones and have flown. Here's some more photos of just people hanging out next to the lava. It's been a really great experience for a lot of people to get really close and to an active lava flow like this. But there's also a lot of really cool drone footage you can find online. A couple of them I want to share with you just because they're really spectacular. This first one is somebody flying a drone up the lava channel and right up to the cone that's actively spattering. And I guess they get pretty lucky that their drone doesn't get hit with some of that spatter, because I've seen videos of drones that did get hit with spatter and it damaged the cameras. Okay, and so the next one I want to show is, this is another cool video taken from a drone showing, and I don't think we need sound, showing so it's sort of low right now, but there's about to be a pulse of activity where it really starts ramping up and getting really bright and spitting out a lot of, the fountaining is going to really increase here and start throwing lava flows down the side here. I like this video because it really shows you in real time how volcanic cones get built from the cumulative, accumulation, the successive accumulation of lava spatter and lava flows, just growing and growing and growing a little bit at a time. So if you could scale this up to the size of a stratovolcano, and that's how they grow, the successive accumulation of lava and pyroclastic debris that comes out of the volcano. Pretty amazing. Now, the current status of this eruption, I think it kind of maybe stalled about a week ago or so, but then it has resumed. Here are a couple of maps showing, so this is near the beginning. Here's the fissure, and this is the lava flows initially filling up Geldingadalur Valley and Mera de Lur Valley. And just as of a few weeks ago, the lava flows have really increased. They've started filling up this valley to the south, which I think is pronounced Nathaya Valley, and it looks like it's in danger of going to the south and crossing some of these trails and eventually the road. So this is something to keep an eye on. All right, let's move to Alaska. The last place I want to visit right now is Alaska, because there are currently at least 3 active volcanoes along the Aleutian Islands that I want to briefly mention. And I don't know how we're doing on time. We're good. So, so far I've shown examples of really kind of not very explosive, effusive eruptions where it's really easy to get close and get pretty pictures of incandescent lava. But I don't want you all to leave thinking that this is typical or this is the only type of eruption that we see. Sometimes eruptions are much more explosive. They're located more remotely, and it's harder to get pretty pictures of them, but they're no less important in terms of the hazards that they produce. And so the first, I want to look at Pavlov volcano, and then we'll look at Great Sitkin, and then we'll look at one called Semisopochnoi, which is a fun name to say. So Pavlov volcano, this is one of the most active volcanoes in the Aleutian Arc, actually, and it's located out on the Alaskan Peninsula, and it started erupting again last month, and it's had elevated seismicity, elevated surface temperatures. We can see sulfur dioxide emissions in satellite data, and numerous intermittent explosions have sent ash up 3.5 kilometers, about 12,000 feet. Okay, and so here are a few photos from Pavlov in the last few weeks. And the next one is Great Sitkin volcano, which is a volcanic island that's out in the central Aleutians. Earlier this year in May, some thermal anomalies were detected using satellite infrared images. And then there was this increase in seismic activity and volcanic gas emissions. And on May 25th, there's a pretty big explosion that was actually heard by some local mariners who were about 40 kilometers away. And that produced a pretty big ash plume that rose 4.5 kilometers up, about 15,000 feet. In July and in August, there were satellite images that confirmed that there's actually a lava dome growing in the crater. And this image here shows some possible low-level, this is from August here, some low-level spattering, this incandescence up here. And as of now, it looks like there's a lava dome that's growing. It's about 1,000 meters wide and 30 meters thick. And that's what's happening at Great Sitka. And the other one is Simisopochnoi. This is a large, pretty young volcanic island way out in the western Aleutians. I mean, almost all the way over to the international date line. It's got an 8-kilometer wide caldera in the middle of the island, and numerous other volcanic features, cones and craters. And one of the mountains sort of in the middle or on the edge of the caldera is called Cerberus. And it's named after the 3-headed dog in Greek mythology that guards the gates of the underworld. So Cerberus has been having small explosions and steam and sulfur dioxide emissions and low-level ash emissions recently, up to 15,000 feet. And the ash can drift hundreds of kilometers downwind, and that's an issue for aircraft, and that's why we monitor these volcanoes that are so remotely located, uninhabited. We still have to warn aircraft of the possibility of ash clouds. And the reason I saved this one for last is because actually I just got an email this morning that the eruption here has ramped up in frequency and intensity just in the last day. Several explosions have been detected in the satellite data. They see sulfur dioxide increasing and ash cloud up to 15,000 feet. And so they raised the aviation color code and the alert level just today to red warning this morning. And so that's pretty exciting. So I wish I could just keep going and talking about all these volcanoes, but I want to make sure we have time for questions and all of that good stuff. So I'll stop there and thank you, and take any questions that come in over the internet. I hear all the applause. Should I stop sharing my screen?
Yes, thank you, Greg. You can stop sharing your screen if you'd like. And then, Claire, do you want to start with the questions?
Yes, so we have a couple from the Q&A. So we'll start off with the first one. So Donna Weistrop asked, how are volcanoes under the ocean detected?
Yeah, that's a good question. A lot of them aren't. There are, it depends on how deep they are. There are some volcanoes that are they're under the water, but they're not that deep. And so that when they do erupt, there is disturbance at the surface. You can see a little thermal anomaly in the water. Sometimes you get volcanic rocks like pumice floating in the water. And that's an indication that a shallow underwater eruption might have just occurred. But eruptions that happen deep down at the mid-ocean ridges, man, it's really hard to detect them. There are seismic networks around the world. And so if an eruption causes and makes enough seismic noise, you can detect it and locate it using seismic triangulation. There are, on very rare occasions, deep diving submersibles that go down to mid-ocean ridges to visit the hot springs and the deep sea hydrothermal systems. On very rare occasions, they have witnessed volcanic eruptions in the deep ocean. And there are a few videos of those out there, really deep eruptions, but mostly they don't get noticed unless they make enough seismic noise for us to detect them using the seismic networks that we have. They're really hard to find.
That was a great question. We do have a comment that said, yay for the Star Wars reference, Greg. So that's a good one.
Yeah.
We do have another, and the question is kind of two parts. So which type of volcanoes are the most hazardous and where are they located?
Yeah, I think the volcanoes that tend to be the most hazardous in terms of to people's health are the really big explosive stratovolcanoes, like the ones in Alaska and Kamchatka and Japan and the Philippines and Indonesia, the western coast of the Americas. Those are really hazardous volcanoes. The ones that are really explosive and send out a lot of ash into the air, because ash is one of the primary volcanic hazards, because in the air, it's hazardous to aircraft. And when it settles down to the ground, it can, cause crops. It's hazardous to breathe. It causes poor visibility, can contaminate water supplies. It can collapse roofs. And even if you're not near the volcano, volcanic ash can be a significant hazard. If you're within striking distance of a volcano, then these really hot currents of ash and debris called pyroclastic flows that flow down the side of a mountain are also very, very dangerous.
That was also a good question. So while we're waiting for hopefully a couple more, I have a question for you.
Okay.
And with potentially several eruptions happening at any time, anywhere in the world, how do you as a scientist decide which one to go study?
Well, it's an interesting question. Yeah, there are a lot of volcanoes going on at any given time. And depending on and they're all being monitored. All these volcanoes, in the country where they happen, there is a volcano observatory that's responsible for monitoring them. And so when you say study, there's monitoring, which is like, this is active, this is real, this is happening right now, this is causing a crisis. We need to, this is not, like for a volcano that's causing a crisis, you're not doing volcano science research on that volcano. You're doing work to protect people and protect property, whatever you can. You use science, of course. But for volcanoes that are not currently erupting or might erupt again, and then you have time to sort of sit back and do some really in-depth scientific research on it. How do I choose? I don't know. I mean, I choose the ones that I think are interesting, and the ones that I have opportunities to explore. So, I've done a lot of work in Yellowstone and in Hawaii. I've also had an opportunity to go to Peru before and see a volcano eruption there. And just a month ago, for example, Vaughan volcano, which is in the Northern Mariana Islands, which is a U.S. territory, that one had a minor low-level ash eruption. We were watching it, and I was sort of for a while. I was just sort of daily keeping track of the sulfur dioxide and ash emissions from that volcano. So far, it looks like it's calmed down right now. It just was a little short, low ash emission eruption. But someone called my attention to that, and they said, "Hey, Greg, will you take a look at this and help us monitor it?" So yeah, sure. And now I learned a little bit about Vaughan volcano doing that. And so maybe someday I'll do a research project on it. Who knows?
Thank you. So we have a question from Dr. Awe. Is there any idea of when another major eruption like that of Krakatoa may occur?
Yeah, that's tough. Yeah, you can't predict volcanic eruptions very, very far into the future. There's just no way to predict when they might happen. Only when they start waking up and giving you signs that they're waking up, like earthquakes and ground deformation and volcanic gas emissions and volcanic heat emissions. Only then can you start to try to forecast, okay, based on this volcano's history, it tends to have these types of eruptions. They tend to have this frequency. And so there's a lot of historical research that goes into every individual volcano. You want to know about its history, its periodicity, and then if it starts to wake up again, you can learn what sort of signs and signals it exhibits before it might erupt. And the really tricky part is sometimes volcanoes do everything you expect them to do, and then they don't erupt. And that just throws another kink in the works there. So it's a very hard thing to do. I don't know the answer when the next really big eruption is going to happen.
That is interesting to know. That makes sense, though. We have a question. How concerned should we be regarding explosive eruptions near Flagstaff?
Near Flagstaff, I would say not concerned. I would not be concerned about that. We are living here in the San Francisco volcanic field, which is a large field of volcanoes that are geologically pretty recent. I wouldn't worry about San Francisco peaks. They haven't erupted in a million years, so that's what we would safely call an extinct volcanic system. But as you probably know, Sunset Crater is a relatively young, less than 1,000 years ago, it erupted. So it's possible that there'll be a future eruption here in Flagstaff, although there's no indication of that right now. But it's possible that there's still some magma down beneath the San Francisco volcanic field that could work its way up to the surface again someday. Sunset Crater was not a very explosive eruption. It's called a cinder cone volcano, and so they tend to have sort of a lava spattering, forming a little hill kind of thing, and then it lasts for a few years and then it's done. So that could happen again someday, but it doubtful it would be a very explosive one.
So we have an interesting question for kids interested in volcanoes. How does someone become a volcanologist?
Okay. Yeah, well, there are a lot of different paths to that. There are a lot of different ways to do that. I can tell you about my path. I became a geologist in college. Well, even in high school, I was really interested in earth science. And I liked the sciences in general. I took every science class I could. And I also liked math. And in college, I studied geology and eventually got into studying volcanoes. And I studied the use of a lot of different geological tools and techniques for studying rocks. I studied geochemistry, and then I studied geophysics. How do you understand the processes that are happening in the earth? And I got to say, there was a little bit of luck involved. I had the opportunity to start working on start using remote sensing tools to study Mount St. Helens when it started erupting in 2004. Back a long time ago now. But there are other paths. You could go into you could be a chemist, and you could really become interested in studying the gases that come out of volcanoes or the waters that drain volcanic areas. And you could study volcanoes from the perspective of a chemist. How do the chemicals change that are coming out of a volcano, and what does that tell us about how the volcano is evolving? Or you could be a geophysicist and you could study seismic waves. A lot of people who study seismology are people who are really into math and computer science. You could be a computer science whiz and be really good at writing code, programming. There's a huge demand for people who understand science and also know how to write code. And so I'd recommend, if you're in school, take computer science classes, because there's a high demand for that. So it's just lots of different paths to become a volcanologist.
Wonderful. So we have another question that kind of diverges more into tourism and visiting volcanoes. So how can the visitors to the volcano in Iceland be certain that the explosion isn't going to go rogue? Are the visits as risky as they seem to me? I haven't been to Iceland. It's high on my list. I really wish I could get a chance to go, but I don't know when I might be able to get to see that. I did get to go to Hawaii in 2018 when it was erupting quite spectacularly, but that was an effusive sort of lava oozing out kind of eruption, not very explosive. And based on the history of that volcano in Hawaii, and also the history of the one erupting in Iceland, that's the kind of eruption we expect. We expect it to be a not very explosive, more effusive, and that's the type of volcano you can actually, you can walk right up to, and you can take your hammer and scoop up some lava as long as you're relatively careful. It's not super dangerous, although you do have to be careful and you have to take precautions. The lava can surge sometimes faster than you can walk, and so you need to have your escape route planned. But there's so many people who have been there visiting it, and I don't think there have been any issues at all with injuries or really bad safety problems. I think going to visit a place in Iceland like that would be relatively safe, and I think there are officials out there, volcanologists and other experts who can warn you where to go, where not to go. There are definitely zones that are shut off, not just because of potential lava flow paths,
they close areas where the lava flow could potentially, but they also monitor the winds, and the sulfur dioxide fumes, gases that are coming out are also very hazardous. And so they're going to close down any area that's going to be inundated with dangerous sulfur dioxide and other gases. So I think they're pretty good about closing areas that are really dangerous.
So we have time for one or two more questions before we make some ending announcements and kind of close off the webinar. So another question is, can the thickness of the crust on the lava lake at Kilauea be measured?
The thickness of the crust, you mean just the top, or the I'm not sure if the whole lava lake?
I'm assuming just the top. Yeah, I'm not sure.
Yeah, this is one of the reasons it's so hard to do this via Zoom without a live studio audience that you can clarify with. Let's see. Well, when molten lava comes out of the ground and is exposed to the atmosphere, it starts cooling very, very quickly, and it forms a little thin crust on it almost immediately. And you can see that in images where the very bright red incandescent lava starts to get dark and crust over. So a little crust of really it's glass, volcanic glass forms in the surface. And sometimes that cracks and the molten material seeps through. But then, like I say, it cools very quickly, almost immediately. And then within minutes, you probably have a crust that's inches thick. And this depends a lot on how hot the volcano is initially and what it's flowing across and whether it's raining and whether the wind's blowing. But within minutes, you get a crust that's an inch thick or so, and within hours, it's probably many inches thick. You could even walk around on a lava flow that's hours old without the danger of falling through, as long as you're careful about where you walk. So it cools pretty quickly, but then rock is also pretty insulating, and so it stays. The core can stay hot for a very long time. So in Kilauea, for example, where the lava lake has crusted over, it's still probably really hot underneath, and nobody's been down there. It's not safe to go down there and walk around on it yet, but there's a very thick crust on it at this point.
Sweet. So we have one more question, and I think it's an interesting one to kind of end off with, and it's, can magma chambers be mapped seismically?
Yeah, that's a really cool thing, because there are some techniques for interpreting. Yes, sort of. There are some techniques. It's called seismic tomography, and they use seismic waves to sort of try to image in 3 dimensions, kind of like a CAT scan, to try to image in 3 dimensions where possible magma reservoirs exist. Very basically, seismic waves travel through the Earth at certain speeds, and when seismic waves will travel more quickly through cold, very solidified material, and they will travel more slowly through material that's very warm. And certain seismic waves won't travel at all through material that's molten. But if you have material that's sort of plastic, that oozes like silly putty, seismic waves will travel through it, but just at a different rate. And so there are techniques where they can, with an array of seismic measuring instrumentation, seismic waves will travel through, and the travel times of the different seismic waves that arrive at each seismic station, that can be interpreted using some computer modeling to try to figure out where the hot rocks are at depth, and then that is interpreted as, okay, that's probably where a magma chamber is. And that's not my area of expertise, but that's my best sort of explanation of how they do it. But they can do it, and it's sort of an emerging new field in the last 10 or so years. It's actually really cool that they can do that.
Nice. That is really cool, and that's exciting to hear about more emerging fields. It's always fun to hear about new science and how it's being used in different fields. So I think that's our last question that we have at the moment, and it is about 6 o'clock. So I just want to thank everyone for coming today to this talk, and thank you, Greg and Dr. Vaughan, for speaking to us was really wonderful and
Happy to do it.
informative. We had some good feedback. I just want to let you guys know, for the attendees still here, for more festival events, you can go to slyfest.org or check out your passport that you may have picked up. And we are doing a survey, so you can enter to win a pair of AirPods by completing the survey. So you can do this right after this presentation. And if you go to more events, we'd like you to complete the survey after each event, just so we can hear how each event was as it's fresh on your mind. And again, each time you enter, you can win a pair of AirPods. So however many times you fill out the little survey, you can be entered to win that many times. So that's kind of exciting. But thanks again, everyone. We hope to see you for more events for the next coming days for the rest of the Flagstaff Festival of Science. So thank you all and have a good evening.
Thanks, bye.